In this video, we're going to tie together multiple factoring strategies in order to factor polynomials completely. So far in algebra class, we have covered four main factoring strategies. The first strategy we covered was factoring out the greatest common factor. The second strategy focused on factoring a trinomial using what's called the ABC method. We then had special factoring strategies that we could use when the A and C values were perfect squares. And then we used factoring by grouping when we had something that contained four terms. So what we're going to do in this video is we're going to use all four of these in order to factor slightly more complex polynomials completely. So in front of you, you'll see the Factoring Polynomials document. And if you need a copy of this, please talk to me in class and I will get you a copy of it. But this is a guide to help you factor polynomials completely. So this is where we're going to mix all of our factoring strategies together, and we're going to use this document to guide us. So if you look off to the side, the upper left-hand corner, you'll see a couple of general hints. It says always arrange your terms by degree, so put the highest degree first and the lowest degree last. Then secondly, it reminds you to always check for a greatest common factor first. We'll talk about that as we get started. And then these other two items are just reminders that some polynomials only have a greatest common factor of 1. Those are just called prime. And you can always check your answers by multiplying out your factored form if you so choose. So, as a guide through this document, you will notice that we always start by factoring out the greatest common factor. So what we're going to look for first is, does the whole polynomial have a greatest common factor? And if it does, we're going to factor it out. And then from there, once we've factored out the greatest common factor, we're going to decide how many terms are left. And depending on the terms that are left, we're going to follow the various branches that you see. And so as we tackle each problem, we're going to go through and we're going to follow this document as a guide to help us fully factor the polynomials we'll see on the next 4 slides. So above you will see a polynomial that's a little more complex than the ones we've seen in the past. And what we're going to do is we're going to use our factoring chart as a guide in order to help us factor and solve this polynomial equation. So to start, I notice that I have my equals 0, which is great because then I know that I can use my zero product property eventually. And then if I follow my factoring chart, which you should have sitting next to you, the first thing you always want to do is factor out the greatest common factor. So here, as I look at 20, 140, and 245, what I notice is that all of these end in 0 or 5, which means that all of them need to be divisible by 5. So I'm going to start off by dividing each of these terms by 5. And then what I also notice variable-wise is that each of these contains at least one x. So my greatest common factor here is 5x. So if I factor out that 5x out in front, what I notice is I get 4x squared minus 28x plus 49, and then that all equals 0. So I started off by factoring out the greatest common factor. Then the next thing I look at is what's left inside of these parentheses, and I notice that there are 3 terms left. So when I have 3 terms left, if I'm following my guide, I notice that I have 2 options here to factor that part underlined in red further. I can either use the ABC method, or I can use one of my special factoring strategies if A and C are both perfect squares. And what I notice here is that A is 4 and C is 49, which tells me that I have a special factoring strategy that I can use here to factor this part in red a little bit further. So we're going to use that factoring strategy, the special factoring strategies, to help us factor that further. So I'm going to square root the 4x squared, which leaves me with 2x, and 2x in the front. And then if I square root the 49, I get 7, so I have 7 and 7. And then because this middle term is negative, I have 2 subtraction signs left inside of there. Now, I need to remember that I still had an original part to this problem. Around those parentheses, I had that 5x that I factored out in front to begin with, and I have the equals 0 off to the right. So what you'll notice here is that all of these parts, where all of the x's are, now have an x that no longer contains a squared. When we see that all of these have been factored completely using multiple strategies, and we see that no terms have an exponent with x having an exponent more than 1, we know that this is fully factored. And once we get to this point, we can actually solve the polynomial equation. And what I notice here is that I have multiplication all across the board. I have 5x times 2x minus 7 times 2x minus 7. And all of that equals 0. So this now is an application of the zero product property. So I can now set each part equal to 0. So I take 5x is equal to 0, 2x minus 7 is equal to 0, and 2x minus 7 is equal to 0. So I solve each part for x. So I find in this first one, x is equal to 0. If I solve this second mini equation, I find that x is equal to 7 over 2. And then if I solve this third mini equation, I find that x is also equal to 7 over 2. So I don't need to mention that twice. I can just say x equals 0 and x equals 7 over 2 are the two values for x that would make this original equation true. So again, I see I have another polynomial on the screen, but unfortunately, all of these items aren't on the same side of the equation. So what I'm going to do to start here is I'm going to move the 25a over to the other side by subtracting 25a from each side, and I'm going to subtract the 150 over to each side because I want to have all of the terms on the same side of the equation so I have an equals 0. So now I'm going to write these all in descending order. So I have a to the power of 3 plus 6a squared minus 25a minus 150 is equal to 0. So that's my first step, is to get everything on the same side of the equation and written in descending order. Then my first step is to always check for a greatest common factor. But if I look for a greatest common factor here between all of these, I notice that not all of them contain a variable, and the greatest common factor numerical-wise is 1. And since the greatest common factor here is just 1, I don't actually have to do that step this time because there isn't a greatest common factor to factor out. So then from here, I notice that I have 4 terms remaining that need to be factored completely. And so if I follow my factoring chart, I notice that if I have 4 terms, I'm going to use the factoring by grouping strategy to help me get started. So I'm going to look at these in pairs and factor out the greatest common factor in pairs. So if I look at this first pair here, I notice that the greatest common factor is just 1a squared, or a squared. So if I factor out an a squared, I end up with a plus 6. And then from here, I know that I want to get a matching parenthesis piece. So if I want to get just a inside of those parentheses, I now need to factor out a negative 25. So if I factor out a negative 25, what I end up with inside of the parentheses is a plus 6. And then I still have that equals 0 off to the right. So here I notice that I have matching parenthesis pieces, which means that I can group these two greatest common factors out in front together. So I can write a squared minus 25 times a plus 6 is equal to 0. Now, I've used one factoring strategy here, but what I notice is that I still have a variable squared. So I have the possibility that there might be another factoring strategy that I need to use. So I take a look at this, and what I notice is that I have an a value of 1a squared and a c value of 25. So here I notice that my special factoring strategies will allow me to factor this part underlined in blue a little bit further. So if I square root, I'm going to put my a plus 6 equals 0 in there. If I square root a squared, I get a. So I have an a and an a in those fronts of the parentheses. Then if I square root 25, I get 5, so I have 5 and 5. And then I noticed that there's no middle term in here, which means that they canceled out and became a 0 for my b value. So I know that because they canceled out that there's a plus sign in one of my parentheses and a subtraction sign in the other. So I used two factoring strategies here. I used factoring by grouping, and then I used my special strategies to factor it a little bit further. And what I notice now is that all of my a values do not contain an exponent that's bigger than 1, and I notice that I have everything being multiplied, and that equals 0. So here I have an application of the zero product property. So I'm going to take each little part and set it equal to 0 to figure out what values for a will give me 0. So I start by subtracting 5 here, and I find that one option is that a is equal to a negative 5. I then add 5 in my second middle mini equation, and I find that another option is that a is equal to a positive 5. And then I subtract 6 in my third little mini equation, and I find a third option is that a is equal to negative 6. So due to the nature of how this equation is set up and the complexities of this polynomial equation that I had to start, I actually find 3 values for a that if I were to plug them back into my original equation, would make that original equation true. So third example, we notice here that we have different terms on different sides of the equation. So we're going to start by rewriting this so that we have all of our terms on the same side of the equation. So I'm going to subtract 130x from each side to start. And then I'm going to make sure that I write my terms in descending order. So the 50x squared comes first because it's the highest degree, followed by a negative 130x in the middle because that's the second highest degree, plus 60 at the end with the lowest degree, and all of that equals 0. So that's my first step there. Then from here, my next step, if I follow my factoring flowchart, is always to find a greatest common factor if I can. Now, all of these don't contain an x, so I can't factor out a variable, but I notice that they all end in 0, which tells me that all of them are for sure divisible by 10. So what I'm going to do here is I'm going to factor a 10 out in front. So I have 10 out in front, and then I have 5x squared minus 13x plus 6, all inside parentheses, and that equals 0. So the first strategy that I used was factoring out the greatest common factor. Then from here I notice that there's still a variable with a squared. So I need to brainstorm whether or not I have more strategies that I can use to factor this further. And since I have 3 terms left, I have 2 options that I can use for if I'm going to factor something with 3 terms, or a trinomial. So I can either use the ABC method, or I can use the special strategies that occur when A and C are perfect squares. And if I take a look at these, I notice that A is 5 and C is 6. So those are not perfect squares, and as a result, I'm going to need to use the ABC method, because I don't have perfect squares for my A and C values, so those special strategies are not going to work. So here I'm going to focus on using the ABC method, and I start that method by finding values for A, which are 5, B, which is negative 13, and C, which is 6. And I need 2 numbers that multiply to A times C, which is 30, and add to B, which is negative 13. So if I start thinking of the factors of 30, I notice that if I have a negative 10 and a negative 3, both of those add to be negative 13, but multiply to be 30. So I'm temporarily going to just focus on this part in red and factor that a little bit further using the ABC method. So here I notice that I'm going to rewrite this as 5x squared, and the negative 13x I'm going to write as negative 10x minus 3x plus 6. Then, using the ABC method, I break this up into pairs. My greatest common factor in the first pair is 5x. So I end up with 5x times, that's x minus 2. Then I want my parenthesis parts to match, so I factor out a -3 in the second set. So I factor out a -3 here, and that gives me x minus 2 in parentheses. Because these match, I can group together the values I factored out in front. So I end up with 5x minus 3 times x minus 2. Now, we've only factored that part underlined in red. So remember, we have to bring this 10 down. This 10 was multiplied out in front. And we need to bring the equals 0 down. So I've now used two factoring strategies. I've used the greatest common factor and the ABC method to factor this completely to a point where x contains no exponents other than x to the power of 1. So now I can see that I have a prime example of the zero product property. I have 3 items being multiplied that equals 0. So what I can do is I can set each little part equal to 0 and figure out what value for x makes each little mini equation true. So if I look at this first one, I notice that this first one over here does not contain an x at all. It just says 10 equals 0. Well, there's no value for x that will make that true because there's no x in that little mini equation. So this one isn't going to help me find a potential value for x. Then from here, I'm going to solve this little mini equation. So I have 5x is equal to 3, divide by 5. So I find that one option for x is that x is equal to 3 over 5. Now if I focus on the third little mini equation, I add 2 to each side, so I get a second value for x of positive 2. So here I found 2 values for x that will make this equation up here true. And final example here, you'll notice this one looks quite complex. We have a lot of rewriting we have to do before we can actually start factoring. So the first thing that I notice here is that this problem contains parentheses. And if I'm going to start factoring, it needs to be written in standard form with all of the parentheses gone to start. So I'm going to start by distributing this 30x squared in order to get rid of the parentheses in this problem. So here I get 30x to the power of 3 minus 30x squared. So that comes from the distributive property. I then have minus 40x squared is equal to 60x. So that's my first step there, is to distribute. And then I also notice that I don't have an equal 0. I have the 60x on the right-hand side of the problem. So I'm going to then next subtract 60x from each side. So I have 30x to the third minus 30x squared minus 40x squared minus 60x equals 0. Now, I know it's tempting to start the problem from here, but what you're hopefully noticing is that we have like terms here. And as tempting as it is to leave this as is, we really need to combine all of our like terms together before we can start factoring. So this becomes negative 70x squared, then minus 60x is equal to 0. So now that we've combined all of our like terms, gotten rid of parentheses, and made it equal 0, we can finally start the factoring process here. So if we follow our factoring flowchart, the first thing we notice is that we need to find a greatest common factor. And if we look here, the greatest common factor of all of these, because they end in a 0, is 10. And then they all contain at least one x. So we're going to factor a 10x out in front of this entire thing. So we factor a 10x out in front, and then we end up with 3x squared minus 7x minus 6 on the inside. So I've now factored out the greatest common factor, and I see that there are 3 terms left inside of here. And because I have a trinomial, I know that I have 2 options I can choose from. I can choose from the ABC method, or I can choose the special strategies. And because here A and C are not perfect squares, I know that I need to utilize the ABC method. So here we start by identifying A to be 3, B to be negative 7, and C to be negative 6. So I'm going to simplify that part in green by finding two numbers that multiply to a times c, which is a negative 18, and add to b, which is a negative 7. So I start thinking of the factors of negative 18, and I know that if I use negative 9 and 2, those two numbers will multiply to negative 18, but add to negative 7. So then I use those two numbers to rewrite this part in green. So remember, I'm just focusing on this part in green right now. I'll bring down the 10x and the equals 0 in a little bit. So here I have 3x squared minus 9x plus 2x minus 6. And then I look at them in pairs. In the first pair, I notice that my greatest common factor is 3x. So if I factor out a 3x, I end up with x minus 3 in parentheses. And then I want to make the parenthesis pieces match in the second pair, so I factor out a 2, which will get me x minus 3. So then from here, I notice that I have matching parenthesis pieces, so I can group the 3x and the plus 2 together out in front. And then I have both of those multiplied by x minus 3. Now that I factored that part a little bit further, I'm going to still bring down the 10x that I factored out in front using the greatest common factor and bring down the equals 0. So now if I take a look at this, what I notice is that all of my x's have an exponent of 1. And what that tells me is that this polynomial is now fully factored. So now I can focus in on if I have the zero product property. And if I look, I notice I have 10x times 3x plus 2 times x minus 3 is equal to 0. So it's a great application of the zero product property. So I can take all three parts, set them equal to 0. So I have 10x equals 0, 3x plus 2 is equal to 0, and x minus 3 equals 0. So for the first one, I divide by 10, so I find x is equal to 0. Here, I subtract 2, and then divide by 3, so I find a second option of x equals negative 2 over 3. And then here, I add 3 to each side, and I find a third option of x is equal to 3. So these three values for x, if I take them and put them back up into my original equation, are the three values for x that will make that equation true.